Okay, this is Donna Nelson, Chapter 5, Stereoisomerism. And so I'm just going to give you 3 very short little demonstrations which you can probably do yourself. So using 2 of them will be with molecular models like those you purchased. So here are 2 molecules that I built using molecular models. This is the ball and stick. These are the straws and the pegs. And so you can make these 2 and you can see that they are not the same molecule. They're the same, but they are mirror images of each other. They are not the identical molecule. They are not identical molecules. And so you can try to put one over the other, but it just doesn't work. And I urge you to make these models, if you don't just like see it easily, make models and move these around and become very comfortable with them, and that will be a way that you will get so that you can see this more easily just by playing with them. That's about the only thing that you can do. Okay? Now, the second thing that I'm going to show you sort of in order, which you could do if you have some polarized lenses. These are simply from some very cheap sunglasses that had polarized lenses. And so you may have experience with Polaroid sunglasses, and whenever you wear these, it really does cut down on the amount of sun that's coming into your eyes. So let's see if I can show you this, what I'm trying to demonstrate. So these are just like the polarizing lenses that are in a polarimeter. And so you can see that light is coming through, even though these are polarizing lenses. Light is coming through, and you cannot tell that these are that the light coming on through is polarized light. And so what I'm going to do is I'm going to hopefully convince you that it is. So I'm going to rotate this and put this over, and you can see that you can see right through both of those. Okay, but if I turn this slowly, you'll see that it totally darkens. And that's what polarized sunglasses with polarized lenses will do. Okay, so what's happening is the light coming off of the paper from beneath is being polarized, so only one plane of light is coming through the yellow sunglasses, and then when it comes on up and goes through or into the lens of the black sunglasses, it's screened out. Okay, and so no light at all is getting through. Now if I turn these back, you can see that the light is coming through once again, because that plane of light is allowed to pass through the yellow sunglasses, and now the way that I'm holding the black sunglasses, it's also allowed to pass through. So if you want to go out and get some sunglasses with Polaroid lenses and tear them up like I did, you'll be able to do this little demonstration yourself. Okay, so there you go. And the third little demonstration I was going to give you was with this model of alene. Remember, alene is the compound that has 3 carbon atoms, 1, 2, 3, and 2 double bonds. Okay, and if you just draw it on paper and you draw carbon, double bond, carbon, it's not so obvious what is the relationship of the pi bonds. And Here I've just put groups on the end just to make them more visible, what it is. And so here, if you look at the pi bonds, you can see that the pi bonds are lying in different planes. Okay? The pi bonds are orthogonal, which means mutually independent. They are totally independent of each other. Okay? And the other thing is, what's the hybridization of these atoms? Notice this atom, this carbon, is sp2 hybridized because you have 1, 2, 3 atoms attached to it, and you have a pi bond. This carbon is sp2 hybridized because you have 1, 2, 3 atoms attached to it and a pi bond. You can see the p orbitals here, which have formed the pi bond. Now this carbon in the middle, look at what it has. It has 1, 2 carbons attached to it, and it has 1, 2 pi bonds attached to it. This carbon is sp hybridized. Okay, you might want to think about that. And I'm sure that it's easier to see if you have a model rather than if you simply draw carbon, double bond carbon, double bond carbon on a sheet of paper. So I hope that this makes it easier for you to visualize.